This is Agriculture Today, and I'm Shelby Varner with the K-State Radio Network. Kickstarting today's show is Josh Ritter, Acting State Executive Director for the Kansas Farm Service Agency, as he talks about the Emergency Commodity Assistance Program and approved farm loans. The 38th Annual Elmer G. Heyne Lecture, Jianming Yu from Iowa State University, keeps the show moving as he discusses the genetic and statistic research he has done on multiple crops. Brad White, Dustin Pendell, Brian Lubbers and Bob Larson from the Beef Cattle Institute in the show with part of their Cattle Chat podcast to converse about how operations may have changed over the years. That and more is coming up ahead. You're tuned in to Agriculture Today, and we start our Wednesday show talking with the Farm Service Agency. And today we're joined by Acting State Executive Director for Kansas's Farm Service Agency, Josh Ritter. Josh, thanks for joining us today.
Hi, thanks for having me.
Josh, currently, what's the hot topic at the Farm Service Agency?
Yeah, one thing we have going on that's really is a lot of program activity right now is the Emergency Commodity Assistance Program, or ECAP. We've seen a lot of activity. That I think the program was announced on March 18th, and already through the applications we got in, we've rolled out roughly $340 million in payments. So,
and what are the payments intended to help producers do?
Yeah, the payments are being made under this program to help producers mitigate the impacts of increased input costs and falling commodity prices. So that's what they're there to help. Since we have seen lower commodity prices, they came out with this program to help with that.
So what's eligible?
Yeah, eligible acreage is any acreage that was reported as being intended for harvest, haying, grazing, silage, or similar purposes. There are some caveats there when it comes to intended use of some of those things and double cropping, things like that. So,
what is that caveat?
So acreage that has been reported with both an initial commodity and a double crop commodity will be eligible for payment on both plantings if the commodities are in an approved double crop combination. If they're not, then it's just going to be that initial crop that was planted that'll be eligible for a payment.
And what are some of those payment numbers, Josh?
Yeah, some eligible commodity payment rates on some of our common Kansas commodities are corns at $42.91 per acre, sorghums at $42.52 per acre, soybeans is $29.76 per acre, and wheat is $30.69 per acre.
Are there any limitations for how much the Farm Service Agency is able to pay out?
Yeah, there are some payment limitations for this program, and that is $125,000 if less than 75% of the average gross income of the producer for the 2020, 2021, and 2022 tax years is derived from farming, ranching, or forestry service activities. And then it's up to $250,000 if 75% or more of the average gross income of the producer for 2020, 2021, and 2022 tax years is derived from farming, ranching, or forestry activities.
How does a producer go about finding out information about ECAP or maybe applying for the program?
Yeah, that's a great question. There were pre-filled applications that have been mailed to producers, so I think producers should have gotten those in the mail by now. So they can fill that out, sign that, and just return it to the office. Producers can also complete an application online at fsa.usda.gov/ECAP or by visiting their local FSA county office and requesting an application. So if you're not comfortable with waiting for that mailed application or don't think something looks quite right with it, just go into your local office and they should be able to help you out.
Also going to mention the marketing assistance loans for corn, grain, sorghum, and soybeans. And what is that deadline and how long is that available?
Yeah, the final availability date for those marketing assistant loans for corn, grain, sorghum, and soybeans is May 31st. And what those marketing assistant loans are, they're short-term commodity loans. So they provide interim financing at harvest time to help agriculture producers meet cash flow needs without having to sell their commodities when market prices are typically at harvest time lows. This allows producers to delay selling the commodity until more favorable market conditions come around.
Anything else you'd like to tell our listeners on this subject?
I just wanted to reiterate that those MALs or marketing assistant loans, they are short-term loans, so they're going to mature on the last day of the 9th calendar month following the month in which the MAL is approved. So that's a 9-month term on those loans to help people market. So.
And while you're in, Josh, wanting to mention farm loan programs and what has been happening in terms of farm loan programs for the year of 2025, for the fiscal year of 2025.
Yeah, definitely off to a busy start of the year with our farm loan programs. So far in this fiscal year 2025, which started October 1st of 2024, we've had 813 direct loans approved in Kansas, totaling a little over $143.5 million worth of money going out. And then on the guaranteed loan side, we've had 88 applications approved, totaling $32.23 million. So total obligations are up roughly 30% over the previous fiscal year.
With this increase in activity, anything you'd really like to remind producers of?
Yeah, it's real important that we have communication with our borrowers and the farm loan program staff. Our staff is able to provide guidance and counsel from the initial loan application through the borrower's graduation to commercial credit. And while it is our commitment to advise borrowers as they identify goals and evaluate progress, it is crucial for borrowers to communicate with their farm loan staff when changes occur. So it's the borrower's responsibility to alert FSA to any of the following: if there's any proposed or significant changes in the farming operation, any significant changes to family income or expenses, the development of any problem situations with the farm, or any losses or proposed significant changes in their security. So if a farm loan borrower can't make payments to suppliers, other creditors, or FSA on time, contact your local farm loan staff immediately to discuss your loan servicing options.
And as always, if people want to find out more information about the Farm Service Agency, where can they do that?
Yeah, they can go really mainly to their local office and speak with them. If not, they can also go to Farmers.gov.
Josh, I appreciate you taking the time to join us today.
Hey, yeah, just real quick before I sign off, just want, put a plug in for our offices. We are dealing with some staffing issues in quite a few places. So our employees are doing the best they can to serve everybody. Just hope we can be patient with one another and know that maybe things aren't going to get processed as timely as they once did just because of some staffing issues. And we're doing our best to get everything done as quickly as we can.
That was Acting State Executive Director for the Kansas Farm Service Agency, Josh Ritter. Before we cut to a break, we're now going to be joined by Ron Wilson, who is the director of the Huck Boyd National Institute for Rural Development at K-State.
This is Kansas Profile. How do we multiply a miracle? Ranchers observe the miracle of birth in their cow herds during every calving season. It's especially valuable when a top-quality cow gives birth. Innovators have figured out a scientific way that the best cows can produce additional offspring, making more top-quality genetics available to livestock producers across the Midwest. It's today's Kansas Profile. Dr. Clay Briner, Dr. Kendra Rockbriner, and Dr. Joel Anderson are the owners of Cross Country Genetics, which specializes in this work. The business was founded by Dr. Kirk Gray, a 1982 K-State veterinary medicine graduate. After graduation, Gray worked for Granada in Texas doing this type of work, and eventually came back to Kansas, where he founded Cross Country Genetics. Clay Briner grew up on a Wabaunsee County ranch, earned a degree in animal science in 1998, and a Doctor of Veterinary Medicine degree from K-State in 2002. He went to work for Cross Country Genetics after graduation. In 2014, Ohio State Veterinary Medicine graduate Dr. Joel Anderson joined the company. In 2020, Dr. Gray retired and the Briners purchased the business. Briner's wife Kendra, also a DVM with degrees from K-State and Oklahoma State, specializes in the in vitro fertilization work. They are supported by a team of skilled technicians. Cross Country Genetics specializes in embryo transfer of beef cattle. This involves a month-long process with each cow, beginning with stimulating the donor cow to produce additional oocytes, which are artificially inseminated with semen from a bull with desirable characteristics. The fertilized embryos are flushed from the donor cow, microscopically examined, and carefully preserved. Those embryos can ultimately be transferred to a recipient cow, which will carry them to full term with a natural birth. The scientific process is managed very carefully. When the embryos are to be frozen, sucrose and then ethylene glycol are used to dehydrate the cells so that they can be frozen safely. When ready for freezing, the embryos are plunged into a liquid nitrogen container where the temperature is a minus 196 degrees. Wow, I thought January's temperatures were cold. In the end, the genetic characteristics of the cow are multiplied, not modified. No surgery is involved on the cow. Cross Country Genetics first opened at the rural community of Keats, population 96 people. Now that's rural. The business then moved to a 320-acre parcel of land where it is today in Pottawatomie County, south of Westmoreland. This Flint Hills rangeland is ideal for care of the donor cows which come to the facility. Cross Country Genetics expanded to a second state-of-the-art facility in central Oklahoma and most recently added a site in Warsaw, Missouri. In addition, many services are performed at the customers' locations across the Midwest. We'll put in 50 or 60,000 miles in a car in a year, Briner said. Recent customer visits took him from Nevada, Missouri to the Sandhills of Nebraska. In addition to embryo collections and fresh or frozen embryo transfer, the business offers ultrasound, pregnancy diagnosis, fetal aging and sexing, and more. The IVF side of the business has doubled, Briner said. It is now possible to determine and select the gender of the embryo. Furthermore, with an intervention at a particular time, it is possible to create twins from a single embryo. Briner served as national president of the American Embryo Transfer Association in 2022. The ultimate goal of this work is to expand the genetic impact of high-quality cows. By the time a cow is 6 years old, she would have had 5 calves, Briner said. Using embryo transfer, by the time she's that age, there could be 25 to 50 calves carrying her genetics, he said. For more information, see www.crosscountrygenetics.com. How do we multiply the miracle of birth, or at least expand and enhance the number of high-quality calves born for livestock producers across the Midwest? We commend Clay Briner, Kendra Rock Briner, Joel Anderson, and all those involved with Cross Country Genetics for making a difference by using science to improve genetics for livestock production across the heartland. They are making miracles multiply. For the Huck Boyd National Institute for Rural Development, this is Ron Wilson with Kansas Profile.
We're cutting to a short break now on Agriculture Today, but we'll be right back. You're tuned in to Agriculture Today, and we continue our show talking with the 38th Annual Elmer G. Heyne Lecture at K-State, and that is the director of the Raymond F. Baker Center for Plant Breeding in the Department of Agronomy at Iowa State University, Jianming Yu. Jianming, thanks for joining us today.
Thank you very much.
Can you just first, to begin, tell us a little bit about yourself?
Sure. I came to K-State in 1998 and did my master's degree. Graduated in 2000, and did the PhD and postdoc, coming back in 2006 as assistant professor at K-State. Worked here for 6.5 years before leaving K-State for Iowa State. Now it was a privilege to be invited to come back to give the Heyne Lecture today.
And what has the focus of your research been in these past years?
Our focus is on the complex trait dissection and prediction, which is for most of the agronomic traits, they're complex, meaning that they're affected by many genes across a genome, but also affected by environmental conditions and management conditions, but also the genetics and environmental interactions. They're complex, but sometimes we want to identify individual genes and then to do the validation. Sometimes we want to do the prediction, which is to make the plant breeding process, the selection process, more efficient.
And what are some key points when you look at that plant breeding selection that you really usually focus on?
We focus on the plant breeding methodology, meaning that anything we discovered about genetic architecture of the complex trait, its interaction with the environment, will help us to design modern plant breeding programs to take advantage of 3 key terms: technology, analytics, and design. By technology, we can mean the sequencing, genotyping, single-cell genomics. By the analytics, meaning that we can do an analysis, we can do the models, we can do artificial intelligence, machine learning models. By design, meaning that we can optimize the design of the plant breeding process or pipeline. We can design a better experiment to contain more signals, less noise, to inform us for the breeding process.
And what different plant species have you been looking at for this research?
Since 2006, when I was an assistant professor at K-State, we started focusing on the sorghum. So after moving to Iowa State, we still keep sorghum as one of the 2 major crop species. The research at Iowa State have the second species, which is corn, and then it's our focus. But we typically work across different crop species, including wheat, rice, barley, oat, soybean, peanut.
How do you go about conducting this research?
Our research contains multiple components. One type of research is typical field experiment. We'll have the yield trial. We'll have the mapping population. We'll have the measurement. We're also doing the genome sequencing and genotyping. That's field focused. The second part of research focuses on the growth chamber greenhouse experiment, where we have the individual genes or individual genetic stocks to be evaluated. The third component is called analytics, meaning that we are focusing more on the data-driven research to discover the pattern in the data, which can inform us to design next stage of the field experiment, growth chamber, or greenhouse experiment. So there's three components.
From when you were at K-State between 2006 and 2012 to where we are now, what have been some big improvements you've seen for these different crops?
Our understanding on the complex trait, architecture of a complex trait, homolog genes, what is their effect size, the locations on the genomes, and their interaction with the environment, and then how do we go best select the individuals out of the large populations have significantly improved. Since the past 15 years, we really latched into this area called phenotypic plasticity. It's a new term that we think is going to establish a broad framework to combine the genomics, technology, phenotyping, analytics, and also the natural field condition, crop production all together to help to move the research forward.
When you're working on that genetic level, do you usually see it create a difference when we look at a plant phenotypically then?
Yes, that's the main research. When you see a genetic differences, you're expecting to see the phenotype expression to be different. But this expression can also be changing depending on the environmental conditions. Sometimes you see the genetic difference enlarged under certain environmental conditions. Sometimes you see that disappears because the environmental condition can suppress the expression of genetics to make the difference to be smaller under the detectable level.
When you say environmental conditions, are you trying to control different environmental conditions, or are you just planting them out and whatever happens with the weather that year happens?
Yes, this is there's some argument saying that whether you rely on the natural field conditions versus growth chamber, growth house, or controlled condition. What we believe right now is that the natural field condition, although is difficult to control, but over the long term, over a large geographic region, over the multiple years, there's still consistent patterns can be mined. But the research out of the natural field condition is better connected with the farmer's field, with the production agriculture, where you want to do research on the well-controlled conditions, things start change. You might not be detecting the actual genetic effect, loci, and also the effect will change. So that's two different systems.
Have you had any surprises within this research?
The biggest surprise we see right now is that sometimes the discovery can be totally unexpected. We have good examples, starting with observing the flowering time difference, where we see in Kansas 2011, 2012, the temperature generally higher. There's some dry conditions, versus Puerto Rico, winter nursery 2010, 2011, which is the tropical environment. And then when we moved to Iowa State, we were observing the similar trend of flowering time close to Kansas because Iowa is north of Kansas. In 2024, there was a cold spell early spring, and then since changed. So you might start with a very surprise observation, but if we have research funding to allow us to keep looking into this unexpected result, we might discover a genetic pattern that can inform many other crops.
What are those big dreams moving forward for this research?
This is the one we, in 2021, we could claim this article title we published called Phenotypic Plasticity as a Framework to Reinstating Environment into the Genome-wide Association Studies, which is gene hunting, gene identification, and genomic selection, which is a prediction and breeding. So we want to emphasize this natural environment condition that affect the phenotype you observe. And then we really want to bring the attention to the environment we're dealing with, that to the level of analysis when we're doing the sequencing and genotyping. Yeah.
As we've talked, obviously this research has taken place or is taking place in Kansas and Iowa, but is there expansion of this research that goes beyond the United States?
Yes. This line of research, we believe, has wide applications into many other crops, many other geographic regions. We actually have the many other scientists following our research. These will be scientists from Europe, scientists from Asia, and South of Africa. And then they're discovering the similar patterns following our methodology.
What does all this mean for the Kansas farmer?
For Kansas farmer, meaning that when the researchers, especially geneticists and breeders, and also coupled with crop physiologists, soil scientists, climatologists, we have a better understanding of the environment, natural environment condition, and manage the environment condition. We have this multiple sensors, technologies to record the data of the weather conditions, soil condition, maybe also plant conditions. With this data available, digitized, we can have a better understanding how each individual crops, each plant are sensing the environmental conditions, eventually to decide their growth trajectories, set the seed, green filling duration, and mature to be harvested to have a bumper crop. So a deep understanding of the genetics, development, environment condition, eventually phenotype, that is very critical to the production agriculture.
If people are wanting to find out more information on your work, how can they do that?
We have website. We also publish news release, and we also share our research to the major companies. And we also have a lot of, presentations at different meetings, conferences.
Jianming, I appreciate you taking the time to join us today.
Thank you very much. I enjoy this process. Thank you.
That was director of the Raymond F. Baker Center for Plant Breeding in the Department of Agronomy at Iowa State University, Jianming Yu, and he is K-State's 38th Annual Elmer G. Heyne Lecturer. I will link some of the resources that he mentioned in today's show notes on agtoday.net. While you're there, you will also be able to find a link if you'd like to find out more information about Elmer G. Heyne or the Elmer G. Heyne Lecture. We're cutting to a short break now on Agriculture Today, but stick around because we have more for you up ahead. You're tuned back into Agriculture Today, and we conclude our show with part of the Beef Cattle Institute's Cattle Chat podcast, where Brad White, Dustin Pendell, Bob Larson, and Brian Lubbers discuss a listener question.
How many farmers have moved from cattle to row crop?
Well, the short answer is we don't know. The USDA does not collect that data, unfortunately. But what we can do is we can speculate.
Perfect. That's what we want to do.
So we do know, they do a census every 5 years. And so people that complete that census, we know how many cattle operations there are. And we know from 2017 to 2022, there was over 100,000 cattle operations that went out of business or didn't at least complete the census survey. So we know that those numbers are going down. We know every year that we've had fewer, at least in the last 4 or 5 years, fewer beef cows. I mean, that's kind of following that cattle cycle, but that could be weather-driven. But what we don't know is, are those cattle producers also grain producers? And if they get out of the cattle business, are they still in the grain business? We don't know. We know that we can tell how many acres there are across time in Kansas, for example. I mean, it changes a little bit, but not very much. But those total acres reported in farms are crops and pasture land, so we can't break that number out. But what we do know is the trend is fewer farm operations, number of farms, the average operation size is going up.
I don't have USDA data, but I'm just aware of a lot of pasture land that's been broken up into crop ground, And so I'm assuming that there's a fair amount of that happening because I see it, in my community and places I go. But then the opposite side, when the CRP program was started, it was really an effort to take marginal crop ground and put it back under grass. Now, as those CRP acres came out or come out, are they going back into crop production or pasture? I have no idea. So the overarching, I think I see more pasture ground going into crop ground, but I'm a little bit torn. I'm not sure exactly what the CRP acres, when those come out, where they're going. I don't know if there's any data on that.
Yeah, I don't know. There's probably data on how many CRP acres there are, how many come out, but are they going back into cropland? I don't know. But I would agree that I think we've seen pastures tilled up and it's going to be marginal cropland, but I don't know how much of it you see going the other way.
And I'll kind of just throw this out because I'm not really sure, but once you take a pasture and convert it to crop ground, you have some inputs into that. I would suspect, since we're speculating, I will speculate that it's very hard to eat those inputs, or at least there's a period of time that you have to stay in crop ground in order to recover that. Even if you wanted to go back to pasture, that you could. That's kind of my suspicion.
Well, one thing as a veterinarian, making my living with cow-calf clients and the number of cows, if this is think that we see fewer acres of pasture land over time, just gradually decreasing, moving into crop ground or something like that, one of the things that I think is really important in order to, maintain good productivity is, I'm going to go back to, good pasture management, get the most out of the acres of grass that we have so you become a good grass farmer, good reproductive efficiency so that we don't have cows that aren't producing the product that we want given the input we have. So I think it puts pressure on all of us in the beef industry to understand we're not making more pasture probably, and so we have to become really good at using the pasture lands, the range lands that we have, and kind of keep an eye on productivity and efficiency.
And there will be some regions where that land is best suited for pasture, which will be much harder to convert to crop ground. And then I think there's lots of other things that come into play, even areas that we have converted, water usage being a big one, some of the other sustainability efforts, Philip, that you've been a part of being big ones. So no easy way to answer this question because lots of diversified operations and the proportion of their operation that is row crop versus cattle may be really hard to measure. But anecdotally, we're seeing the same thing, that there's some conversion. It'll be interesting to see what happens with some of the USDA programs, other things upcoming in the future. And does that have an impact? We don't know yet.
Once again, that was part of the Beef Cattle Institute's Cattle Chat podcast. That's all we have for you today on Agriculture Today, but we'll be back with more for you tomorrow.